Welcome back to our channel, The Classroom. Today we are back with another chapter of Mathematics of Class 10, that is Trigonometrical Identities. Now, trigonometry we have already started in Class 9 and we have gone through many of the chapters along with the complementary angles. Now, complementary angles will be also a part of Class 10, so I'll be repeating a bit of it in examples and obviously the formula which we have used over there. And right now, you can see in the board I have written the reciprocal relations. This we have already studied in class 9. This is just to recapitulate. So sin x is equal to 1 by cosec x or cosec x equal to 1 by sin x. Cos x is equal to 1 by sec x or sec x equal to 1 by cos x. And tan x is equal to 1 by cot x or cot x equal to 1 by tan x. So these are the things which we are going to use it right now in this particular chapter. Okay, so this was all about the reciprocal relations. Now coming to the square relations, I'll write down the formula so that it becomes easy for me to explain it to you. Now, these are the square relations. We have done it in class 9 chapters also. There I have told you that sin square x plus cos square x equal to 1, sec square x minus tan square x equal to 1, cosec square x minus cot square equal to 1. Now these are obtained from that particular right angle triangle. Okay, this is just a workout and then we will come to the conclusion of this part. Okay, so taking this right angle triangle, you can easily see that wherever the acute angle is considered and if the right angle is on the same side, that particular side is to be considered as the base. Have been discussed number of times. This is a perpendicular and the other side is the greater side is the hypotenuse. Now coming to the fact that sin x will be what? Perpendicular by hypotenuse. That means AB by AC. That's what I've written. Cos x is base by hypotenuse, means BC by AC. That's what I've written. Okay. So sin square x plus cos square x, because here it has been said square. So that means we have to square the ratios and add it. So sin square x plus cos square x equal to what? AB square plus AC square. Squaring these terms plus BC square by AC square. Now AC square is taken as a LCM, so AB square plus BC square, which is again the hypotenuse, because we know according to Pythagorean theorem that AC square will be equal to AB square plus BC square. Okay, so that means AB square plus BC square will give you AC square, hypotenuse square. So hypotenuse by hypotenuse equal to 1. Right? Next, coming to 1 plus tan square x, 1 plus AB square by BC square. What is AB by BC? Tan x is AB by BC. Perpendicular by base. AB by BC. Squaring, so is AB square by BC square. So now taking BC square as the LCM, we are getting BC square plus AB square, which is again the hypotenuse. So AC square by BC square. That means hypotenuse by base is what? Sec. So sec square x. So this is another that is relation that we have got. Now coming to 1 plus cot square x equal to 1 plus BC square by AB square. BC by AB is what? Base by perpendicular. So taking AB square as a LCM, we get AB square plus BC square, which is again the hypotenuse, AC square by AB square. Now hypotenuse by perpendicular is the cosec value. So we get cosec square. So this is the third square. Right? So let's come to the summarized part of these square relations. Now this is a summarized form of the square relations. Just see that sin square x plus cos square x equal to 1. We have got that. So we can also write 1 minus cos square x, just taking the cos square x on the other hand side of the equation, we get equal to sin square x. Now again 1 minus sin square x equal to cos square x. Next, sec square x minus tan square x equal to 1. So we have 1 plus tan square x equal to sec square x, or sec square x minus 1 equal to tan square x. And lastly, cosec square x minus cot square x equal to 1. So 1 plus cot square x equal to cosec square x. Cosec square x minus 1 equal to cot square x. These are the things which you have to remember. It's basically these three particular ones which you have to remember, and accordingly you can find these other ratios. This is just bringing it onto the other side. Right? So this was all about the square relation. Now coming to the complementary angles, we have already done that in class 9. This is just for a revision so that we can use it up here also. That is sin 90 degree minus x equal to cos x, and cos 90 degree minus x equal to sin x. Again tan 90 degree minus x equal to cot x, cot 90 degree minus x equal to tan x, and sec 90 degree minus x equal to cosec x, cosec 90 degree minus x equal to sec x. So these are the ones which we have already done, right, using the complementary angles. So here also we'll have this. So let's get started with the examples. Now, this was example that cos to the power 4a minus sin to the power 4a equal to 2 cos square a minus 1. This you have to prove. Okay, so taking the left hand side, that is cos to the power 4a minus sin to the power 4a. So you can take this in square form, that is cos square a whole square minus sin square a whole square. Now a square minus b square formula already you know, that is a minus b into a plus b. So I've written in that formula. Cos square a minus sin square a, and this is cos square a plus sin square a. Now this we already know this as 1. So taking this cos square a minus sin square a, since we have the formula or the result as cos square, right, not in the form of sin square. So change the sin square a to cos square a, that is 1 minus cos square a into 1. So we get cos square a minus 1 plus cos square a, that is 2 cos square a minus 1. So this is your result. Okay, here in the bracket you can easily write, since cos square a plus sin square a equal to 1. This you can write. Okay, that's why we are getting 1 here. Square relations. So this was the first example. Now this is the second example, sec a minus tan a by cosec a plus cot a equal to cosec a minus cot a by sec a plus tan a. So bringing this, we have to show that LH is equal to RHS. This will be proved in some different way. Okay, now what is that? Just see that we know that you can see that this too can be like sec a minus tan a into sec a plus tan a gives you sec square a minus tan square a, right? And here in this case, cosec a plus cot a into cosec a minus cot a gives you cosec square a minus cot square a, right? So in these two cases, these two results we have 1. These two results we have 1. Okay, so in that case, if we take this and this, since the results are same, if we take these two ratios and equate, so we get sec square a minus tan square a equal to cosec square a minus cot square a. So we have this particular thing that was here, sec a minus tan a into sec a plus tan a equal to cosec a minus cot a, cosec a plus cot a. Now sec a minus tan a by cosec a plus cot a, as it was written here, just cross multiply and write, equal to cosec a minus cot a, that is this term, divided by sec a plus tan a. This is how we got the result from the ratios. Okay, that is the square ratios. I hope it's very clear and it's really literally easy. You can easily understand it from this particular question itself, that how you are going to proceed. Right? Coming to the next question. Now the third example. Root over of 1 minus sin a by 1 plus sin a, this whole part is under the root, equal to sec a minus tan a. So the first we are going to take up the LHS part. We have already done in rationalization in class 9. So whenever there is a plus sign, okay, we need to multiply with the opposite sign. Okay, so here in the denominator it is 1 plus sin a, so we are going to multiply in the numerator and denominator with the opposite sign. That means 1 minus sin a into 1 minus sin a, obviously with roots. So 1 minus sin a whole square, we got it from here within the root, and this is 1 plus minus sin a, 1 minus sin a. So this is a plus b into a minus b. So we get 1 minus sin square a. So after this, 1 minus sin a whole square, that means 1 we can take out, since there is a whole square. So 1 minus sin a, we have taken it out. And 1 minus sin square a is, we know it as cos square a. So cos square a, it's again 2, right? That is cos a into cos a, that is which is giving it cos square a. So from here we get it cos a. So 1 minus sin a by cos a. So then 1 by cos a minus sin a by cos a. So we get 1 by cos is what, sec, minus this is tan, which is the RHS. So this was the third example. I said if you learn the formula, it will be very easy for us to solve. Okay, so this was the third one. Coming to the fourth one. Now this is a fourth sum. If x equal to a sec a cos b, y equal to b sec a sin b, and z is equal to c tan a, then show that x square by a square plus y square by b square minus z square by c square equal to 1. Okay, so let's take the LHS first. So put the values of x, y and z here. So we get a square sec square a cos square b by a square plus b square sec square a sin square b by b square minus c square tan square a by c square. These are the values of x, y and z. Then we can cut it. See, a square, b square and c square, c square. Okay, after that we are left with sec square a cos square b plus sec square a sin square b minus tan square a. After that you can see from this to first two ratios we have sec square a common. So I have taken sec square a common. So in bracket we are left with cos square b plus sin square b minus tan square a. Okay, so cos square b plus sin square b, the angles are same, that means that is equal to 1. So we have sec square a into 1 minus tan square a. Now again sec square a minus tan square a, this is another square ratio, that is equal to 1. So this is the RHS that we have got. So this is what we have to show. I said it's very easy, and just remember the formulas. See, here also we have used the formulas, right? Coming to some of the sums from the complementary angles. I've done two examples here. Cos 58 degree minus sin 32 degree. Now you can change either of them. I've just changed the first one only, you can change the second one also. Okay, so that means 58 can be written as 90 minus 32 degree. So cos 90 minus 32 degree is what? Sin 32. So sin 32 minus sin 32, that is giving you 0. And the second example is sin 90 minus a cos 90 minus a is equal to tan 1 plus tan square a. This you have to prove. So let's take the LHS first. Sin 90 minus a into cos 90 minus a. So sin 90 minus is cos a and cos 90 minus a is sin a. So this is a result of LHS. Now take the RHS. Tan a by 1 plus tan square a. Now tan a by 1 plus tan square a, according to that square ratios, we have sec square a minus tan square a equal to 1. So 1 plus tan square a is equal to sec square a. So I have written sin a by because my LHS was cos a and sin a. So I have taken tan a as sin a by cos a. So sin a by cos a divided by 1 by cos square a. Just divide and see. Sin a by cos a divide 1 by cos square a. Sin a by cos a into cos square a. You are cutting it. You are getting sin a into cos a. So this is the same result as your LHS. So I have written LHS equal to RHS. So this was a complementary angles sum. Okay. Now coming to a bit different type of thing, that is using the log tables. Now at the back of your book, whichever book you are using, okay, for class 10, be it the R.S. Agarwal or be it the Concise or the Frank, whichever book you are using, you will see that at the back of the book there will be tables, okay, or you can buy table books also. There are table books which you can, log table books which you can buy. Okay, so for, over there you can find that you have the values for each of the angles of these trigonometrical ratios. Okay, so there we will get some that from that. Choosing those things, we will be solving some of the questions here. Okay, right now I'll be showing you the page where you can get it. Now I have done 3 sums here, taking the different angles, okay, of sine values, cos value and tan value. So the first one is sine 36 degree 51 minutes. Now in your log table you will find where is sine 36. Now I can see, if you are having the book with you, please see that sine 36 and which is the nearest minutes to 51. You can check that it is not 54, it's 48 degree, right? So sine 36 48 degree is, we are having it as 0.5990. Okay, so as we take that, so 51 minus 48 is how many minutes less? It is 3 minutes less. So there in the mean difference you will see 1, 2, 3, 4 and 5. So we will take up the third value. Okay, so the third value is, as you can see, is 7. That means it will be 0.0007. Okay, so in that case, whenever we have the sines value, we need to add these two values of the degrees that we are getting. So we get it 0.5997. Okay, in case of tan also the same procedure. We have to add tan 53 degree 38 minutes. As if you check that tan's value nearest to 38 degree is the 36 value, not the 42 one. Okay, because it's more than that. So we have to take the 36 degree. That is, we are getting 1.3564. You can just check it over here. Okay, then it's a difference of 2 minutes, right? So it is 2 minutes here is equal to, as you can check, it is 16. So that means 0.0016. Now for tan also you have to add up the values. So 1.3564 plus 0.0016. We are getting 1.3580. This is the final answer, right? But for cos, just check, 62 degree, 27 minutes. We have for cos the nearest value of for 27, it's 24, okay, not 30 degree. So there is a difference of 3 degree again, 3 minutes again. So we have this value 62 degree 24 minutes as 0.4633, and the difference of 3 minutes is, here it is given as 8. So that means 0.008. For this cos, we have to subtract the two values. For sin and tan, we were adding, and for cos, we are subtracting. So we are getting 0.4625 as the answer. It's very easy, just know how to take out the value. Just see which is the nearest. If it is already given 60 degree 24 minutes, then it's a simple answer. That is a particular answer of it. Okay, but suppose it is 25 degree. Then that means you have to take the nearest numbers and then add 1 minute to it. Okay, all the values are given here. Okay, next coming to the one more sum, that if we are needed to find out the theta, then what to do. I'll do it here only so that it becomes easy for you. Now here tan theta is equal to 0.8516 is given. Okay, so you need to find out the value of theta. What is the value of theta? Okay, we need to find out this. So first now you just check out this particular value 0.8516 of tangent. Okay, which that is which digits will be closer to it. So after searching, I have seen that tan 40 degree 24 minutes. Okay, we are getting 0.8511, because here you can see there is a difference of only 5, right? 5 minutes. So let's see what it's coming to. So as I saw, the difference of 1 degree, okay, or sorry, 1 minute was given as 0.005. That means if we add this two, we are getting this particular result. So that means tan 40 25 minutes is the answer. So that means theta is equal to 40 degree 25 minutes. Okay, just need to find out that this value or nearest to this value, not more than this value, less than this. Okay, so like suppose 8511 or 8509, like that type of numbers. If you get that, then add, see the differences which if added will get the same number, and find out. Okay, so this was all about this particular chapter, how to use our trigonometric tables and complementary angles along with the square ratios. So nothing you need to know other than the formula. Just put the formulas and find out the sums. This was all about the chapter. I hope you have understood. If not, please do comment, and if you have liked this video, please put a like, share it, and do subscribe. And don't forget to press the bell icon. You will get many more notifications. Thank you. Have a good day.